Hello, this is a introduction or this is a video on the line follower robot. I'm going to show you first the version that has the ability to start from a minor difference of position. It's on this angle here, as you can see, and then it will connect to the line and then it will continue to go. A little bit of a compensation there, and then it goes. So it starts about here at 0.9, and it goes there. Here in the V1 is the starting definition of the, sorry, no. Yes, this is the V1. Yes, so it starts almost a square away, and then it's -3 on the angle, the yaw angle. The robot then moves on this one. The speed is steady, so what doesn't change during the motion of it. And then we're going to see it go down and then it's going to come back. While it's doing that, I'm going to tell you about the other one, which is the line mission without the V1. And in that one, there is shown an attempt to use the a more variable speed control. The similar, it's some sort of, it's similar to a sigmoid, but it's been inverted and absolute values so that it provides some amount of variation to the speed, hoping to slow down during turning processes. However, because this is all defined during the image callback, which only happens 3 times a second, this is not a particularly good way of handling it, and it becomes very jerky. As opposed to this particular, we just saw it, by the way, turn around. As opposed to the original, the V1 will smoothly follow the line. This is using the original calculation of angle velocity, which is a sigmoid. I have tested some variations of the sigmoids also to try and increase the turn radius while keeping the speed intact. However, that has not proved to be particularly useful. This one seems to be the most stable and provides a low amount of oscillation. The robot's going to reach the end here of the beginning again, and it's going to turn around. It has a slightly different behavior when it hasn't found the line yet. It just goes forward. It can be programmed, for instance, to do a spiral. I've used a spiral in another PA. Anyways, here it goes back again, and it's on its merry way. All right, we're going to stop this one, and we're going to go to the line mission without the V1 now. Here it goes. Here's the other launch file. This one has the speed control, and hopefully what will happen is it will see the line and then it will hopefully go down the line in one direction. It often actually happens to like to turn in the more acute angle as opposed to the more obtuse angle, which is more expected. What happens a lot is that it will waffle between finding the line at different parts of the bottom of the screen, and then it will attempt to turn in those directions. Sometimes it seems to be very variable. Sometimes it turns to the left, sometimes it turns to the right. It kind of depends on just what happens and what speed it continues to go at. It's a little variable, and sometimes this does take a while. We are definitely getting a little closer to the line now. Whoop, and there it goes. I think it's decided to go that direction. Yep, there it goes. And by doing this with the variable control of the speed, it's possible for it to hit at a harder angle and not lose track of the line as hard. It's hit the back end. It doesn't see the line anymore, so it's turning around now with the pre-programmed turnaround. And now it will continue on its merry way. However, this particular move command, unfortunately, takes a long time to reduce the wiggles within the line following. So this is a suboptimal uh, choice for generally moving the robot. You can see the variation of that here, and other experimentations were found, but this is going to take a little more time to find something that is a little bit more accurate. Anyways, that is all. Thank you very much. In sum, we did the turnaround at each end, and we can start at a different place. Both of these files start at a different place. You can find that information in the launch file.